Hi, sixth graders. We're still in order of operations unit. Our lesson for this video is properties. So title that on your page. Our learning target is being able to identify properties from mathematical expressions and using properties to solve problems. So some of our vocabulary. First of all, what does it mean or look like to have equivalent expressions? So we can write things differently and they can still be equal. So we could write 7 plus 8 and it could still equal 8 plus 7. We could write 1 plus 2 and it could still equal 0 plus 3. So that means that they are equal on both sides. This is an expression and this is an expression. A property in terms of math, I know there's other properties and definitions of properties, but a math property is basically a rule or a statement that is stating that if this is happening on one side of an equation, then it needs to be like this on another side of an equation. And we're going to learn a bunch of properties in this video. So these are some of the properties that we are going to learn, and you can write the definitions down as we go through them in the video. All right, distributive property. So each property that we go through, make sure you write it down. You want to have a definition and an example. So the definition of distributive property is to multiply a sum by a number, multiply each addend of the sum by the number outside the parentheses. So here's an example. If we have 3 times 4 plus 6, that is the same as distributing and doing 3 times 4 and 3 times 6. And then if we look at it the opposite way, if we have 5 times 7 and 5 times 3, that's the same as doing 5 and then combining the 7 plus 3 and just multiplying it that way. So let's look at some examples because I know that's a little bit confusing. So use the distributive property to rewrite each expression. Then we're going to solve. 6 times 3 plus 4. So obviously we know that by order of operations, if we used order of operations, we would add inside my parentheses and then multiply times 6. Sometimes, most of the time, the distributive property helps us with bigger numbers and it's easier to split it up sometimes. So the way that this would work, starting with a really basic problem, instead I would do 6 times 3 and 6 times 4, and then I would add them together. So 18 plus 24, and then we would add it that way. So 24, I know 24 plus 20 is 44, and then subtract 2 because 18 is less than 2, so 44 minus 2, my answer is 42. And if I was to do it with my order of operations, then I know that I would do 3 plus 4 is 7 times 6, and I would get 42. Okay, going the opposite way, if I have 2 times 2 plus 2 times 5, I can rewrite it using the distributive property and just do 2 times and then 2 plus 5. So I take my 2 and I take my 5, I put it inside the parentheses. So now I can solve, which is 2 times 7, and it's 14. I know right now with these problems it seems a little pointless, like you can look at this and just be like, yep, I know it's 4 and 10 and 14, but to understand the distributive property, we're just going to start with basic problems right now. So we have 9 times 5 plus 1, so 9, distribute it to the 5, distribute it to the 1, so 9 times 5 plus 9 times 1, so 9 times 5 is 45, plus 9, and we get 54. All right, how can using the distributive property help you to be more efficient and more confident in your problem solving? For example, like how would it come in handy for a problem like this? So the Tour de France is a cycling race through France that lasts 22 days. If a cyclist averages 90 miles per day, about how far does he travel? So I would do 90 times 22, and then I could sit there and I could try to do over here, do 90 times 22 and multiply that out. Or I can split up my 22 into two numbers that would be easier to multiply, and I could do 90 times 20 plus 2, because 20 plus 2 equals 22. And then I can distribute out my 90 to both, so 90 times 20 plus 90 times 2. So when I have numbers that both end in 0, I can just do 9 times 2 and get 18, and then add my zeros. So take off the zeros and then add them back on. So I know 90 times 20 is 1,800. And then here I can do 9 times 2 is 18, and then add back that 0. So 1,800 plus 180 would be 1,980. And what's the question asking me? About how far does he travel? So 1,980 miles. All right, here's a few more properties that you may have heard of before or not, but let's write down commutative property, which means that the order in which two numbers are added or multiplied does not change. So order does not change their sum or product. We can see A plus B equals B plus A, and A times B equals B times A. So 3 plus 4 is the same as 4 plus 3. 3 times 4 is the same as 4 times 3. Because I know that 7 equals 7 and 12 equals 12. Same no matter what the direction is. Notice that it's only for addition and only for multiplication, because we know if we change the order in subtraction or division, it is not going to be the same. So commutative property is only for addition or multiplication. And then we have the associative property. The way in which three numbers are grouped when they are added or multiplied does not change their sum or product. So again, adding and multiplying. A plus B plus C, and then if we change the parentheses, but we keep the same order, then it's still the same. Or we can even change the order, because we know that it doesn't matter if the order is changed, and change the parentheses. So an example here could be 1 plus 2 plus 3 is the same as 1 plus 2 plus 3, and then I put the parentheses there. Because remember, when we solve, we'd solve parentheses first. So here I would solve 1 plus 2 is 3 and add 3, I get 6. Here I have 3 plus 2 is 5 and add 1, I still get 6. The identity properties, so identity means yourself. So that means that the sum of an addend and 0 is the addend, or it stays the same, and the product of a factor and 1 is the factor. So if I take a number and I add 0, it's going to stay the same. That's the identity property of addition, is that adding 0, as we know, does nothing to the number. The identity property of multiplication means that I take a number, I can multiply it by 1, and it also stays the same. So adding 0, multiplying times 1, the number will stay the same. All right, so we did some examples in the previous slide. So if you wrote those examples down, you don't necessarily need to write these down, but you could pause me and you could write an example down on your notebook just to make sure you understand which one. Commutative property of addition, I could do 6 plus 10 equals 10 plus 6. Commutative property of multiplication, 22 times 4 equals 4 times 22. Associative property of addition, 3 plus 9 plus 12 equals 3 plus 9 plus 12. Multiplication, 10 times 4 times 5 is the same as 10 times 4 times 5. Identity of 1, remember, could be 99 times 1 equals 99. Identity of 0 then would be 99 plus 0 equals 99. All right, now you try. So pause this video, write down the expressions, write down what property it is, and then come back and check your work. So here we have, sorry, it's a little cut off and I'm not sure I know how to get this side off of my video. But we have 1 plus 2 plus 3 equals 3 plus 1 plus 2. So that is going to be commutative property of addition. 4 times 5 plus 7, and then that 4 was distributed out to the 5 and the 7. So this is the distributive property. 5 times 0 equals 0. This one I just realized I haven't covered yet in this video, but this one is going to be called the 0 property, and it's on the next slide, so I apologize for that. 12 plus 3 equals 3 plus 12, so that again is the commutative property of addition. This one, 2 plus 1 plus 5 equals 2 plus 1 plus 5. That's going to be the associative property of addition. And then we have 16 equals 1 times 16. So that's the identity property of 1. Okay, so now we can use the properties that we just learned about to help us solve problems mentally, like in our heads, in an easier way. So if we look at this example right here, 4 times 12 times 25, well, if I just switch the order around, 4 times 25 is 100, and then I just know 100 times 12 would just be 1 times 12, which is 12, and then add the zeros. So if I look at 40 times 7 times 5, and if I switch it around, I know that 40 times 5 is pretty easy for me to do, and then times 7. So 40 times 5, I know that 4 times 5 is 20, and add that 0, so 200 times 7. Then I would just do 7 times 2 is 14, add those 2 zeros, and I get 1400. That is way easier for me to do in my head than trying to do 40 times 35, which I really wouldn't be able to do in my head. I would have to stop, write it down, do the process. I would still get 1400, but this one's a little bit easier. And then if we look at 89 plus 15 plus 1, well, if I just flip it around again using the associative property and also the commutative property, I can do 89 plus 1 plus 15. Because 89 plus 15, I have to stop and think. 89 plus 10, then add 5. But if I have 89 plus 1, which is 90, it's a lot easier for me to do 90 plus 15, which is just going to be 105. All right, here's an overview of the summary of properties with examples. So again, if you didn't write them all down, now's your chance to get them written down with the name, with an example. And here's the 0 property that we didn't get to talk about before. But that just tells us that anything multiplied by 0 is going to equal 0. So add that to your list of properties. 2 times 0 equals 0. 100 times 0 equals 0, which most of us already all know that anything multiplied by 0 is 0 anyways. So that's all that I have for you. Get those notebooks into your backpack so they can get to school, and I will see you tomorrow.